Are we doing it at the same time?
Yeah.
Okay, good morning everyone. Hello. Let me just make a few little changes here. Let's do that. Cool. Hey, good morning. Mic looks okay, volume's okay, stream's okay. It feels early. How come we don't cover dictionaries yet? We covered dictionaries. We covered them twice. Week 1 and week 2. Good morning, good morning. On another dreary, rainy day. Looks like I've got some tutors in the chat. Got Simon. I've made him a moderator. I don't know what that means, but enjoy, Simon. It's week 3. Yeah, don't freak me out, Sienna. Jesus, it's not week 4 yet. Yeah, it goes quick, doesn't it? This is so we're a third of the way through the course, sort of. So I hope everyone's gotten started on their group projects. That's the takeaway of that then. Cool. Well, morning, Simon. All right, it's 6 past, so without further ado, let's get to it. So this week, if you looked at the lecture timetable and the topics, you'll know we're talking a bit more about some Python concepts, but specifically around code quality and things like that. But for 3.1, the first mini lecture, we're talking about objects. So this is actually a very, very important lecture. We have sort of skirted around the fact that Python uses objects very heavily, and we've never actually formally introduced that to you. We've never actually told you what objects are. And if you've just come from 1511, and that's your sort of main experience in programming, there are no objects covered in that course. And so you might be feeling very confused about some of the ways that Python's working, especially if you're trying to understand it, which hopefully you are. So this lecture isn't designed to teach the paradigm of object-oriented programming, but to introduce how objects are used in Python and how objects are used in programming sort of more generally, but not heavily focused on object-oriented programming. Like I've said in the past, there's an entire course for object-oriented programming. However, we do use objects in this course. So why are we talking about this, and what are objects? So the reason we're talking about this is because we're using objects every time we use Python. And we've just sort of been lying to you so far and not really talking about it. So it's time to actually get under the hood a little bit and talking about the object model and talking about how it works in Python and why it's important and why it's sort of being used. So first of all, what are objects? So objects came about, so if you go back in time to the 60s and to the 70s, the first programming languages were what are known as procedural languages. So think of your C-esque programming languages. In C, you write a sequence of procedures or actions that the computer executes sort of sequentially or procedurally. And in the C programming language, we have this ability to create structs or records. So if you have a look at the first example, I know this is a little confusing because it's got a hash there, but this is just trying to say that this is some C code here. So in C, we can create a variable, variable. In this case, it's an integer called A, and it procures us a piece of memory large enough to store an integer in memory. Okay, and these are the basic data types. So you should know all of this from 1511. We also had this concept of structs, which is, again, some more C code here. And structs are basically helping us solve the problem where we want to group related data into a singular variable identifier so that we can more easily pass around, manipulate, handle a group of information. And again, nothing new here. So for example, a really common struct type is a point, which is a structure that contains two integers within it called x and y. And you can see that when we create a variable of a type point, the operating system will be requested to allocate 8 bytes of memory because we need the space in memory for two integers. And this is pretty straightforward. This is how we teach it in 1511, and this is how C works. And this should all be making sense to everyone as a little recap. What happened as programming became more mature, as programs got larger, as the types of problems that programmers were solving in industry got more sophisticated, more significant. Some would argue that historically the scaling of these types of applications became quite difficult because there's just so much, we were storing so much data and the programs were doing so much, and now we're writing systems for the financial industry and all these critical systems are being written, and it was becoming difficult to scale typical C-style applications to solve certain types of large business problems. Okay, so some of the ideas around the time that floated and has essentially become very successful is the idea of a new way of thinking about programming. And in this new way of thinking about programming, rather than just having structs, the idea is that let's basically have a struct, right, that can store some data. So in this case, I'm just going to grab up a little whiteboard here. Let's see here. Oops. If I just go create a new one. Maybe I need to refresh this. There we go. So the idea was that basically rather than just having a struct with some data, right? So this is like a struct. This could be X, this could be Y, whatever. A way that was thought about that we could start solving larger scale problems was to have this idea of objects. Now, what is an object? An object essentially, I've got a bit more space here, is a struct. So it's a container for some data, right? So it could still contain an X. It could still contain a Y. But rather than only storing data, it could also store functions. So it could store something, like do something, which doesn't contain necessarily data or information, but contains the sequences of something to do. And this is basically what an object is. Structs were just containing data, okay? Objects contain data and functionality, but all related, like structs, to a single concept. So for example, this is the point struct. This would be the point object. And all of these variables and methods relate to that point or to the type of the object that's stored. So you're basically not only storing like data or related data, but also functionality that operates on that data. And this is basically what an object is. And if you understand this concept, and we'll talk a bit more about it throughout this lecture, but if you understand this concept, a lot of the things that's been happening in Python will start to click and make sense. So I've seen some forum posts and things where people have asked, how is this working in place? Why is this working? And it's because we have objects. And so what's really common with our objects is that, so for example, this method reads or changes its associated variables. Now, here's where the sort of interesting thing about Python comes. Almost everything, pretty much everything in Python is actually an object. So, what does that mean? When I make even an integer in Python, okay, or look, for example, this list, a list containing three values, 1, 2, and 3. What list is the identifier so let's say I've got list is equal to a list. What list actually is a pointer or a reference to a piece of memory that contains the data that I assigned it. So basically, list is actually a reference to an object containing the data. And when I create, for example, a list, we actually get a list object. So rather than just getting the data, 1, 2, and 3, there would also be a number of associated methods with that list. When I say the word method, actually, this is something good to talk about. So functions, we have functions in C or whatever. When a function is on an object, that's when it's typically called a method. So when I say method, I'm actually talking about basically functions that belong to an object. So I know this is all a bit abstract, so let's get some code going. Here, yep. Now I'm going to have to zoom in a little bit. Can we all see that okay? Whoops, that's too much. Okay, so let's go to our example. Can you all see this is way too big. Can you all see the code okay? Let me know if you can't. So here what we're doing, well, let me actually do the list example. So list is going to be assigned 1, 2, and 3. Now, if I just print this list and I run this code, you see that we assign list the values 1, 2, 3, and then we can print that out. But what is list actually? Well, list is an object. And this is actually saying here, well, for example, in VS Code, right, when I do list dot, I'm not just seeing the data that's inside list because of like a struct. I'm seeing all the methods associated with the list object. So somewhere in Python, someone has designed what a list object can do and what it knows. And these are some of the things that it can do. So for example, there is a method called reverse on list. Where did this come from? It's in the definition of what a list object can do. So now if I run this code and print it, you can see that my list is reversed in place. So I asked the list object method to modify the data that it contains. Oops. This is a method. It can read and change the object's variables, basically. Any questions with this so far? So again, if we go back to our whiteboard here, come on, open. There is basically a reverse method here, which contains the instructions for, how to read the values, how to change them around, and then that object gets modified so that it stores them in a different order. And so if we again think about why object-oriented programming came about, programs are getting larger, it's getting harder and harder to maintain what programs do and avoid spaghetti code situations. So the idea is that let's group functionality based on the objects itself. So that things are sort of abstracted, contained, and easier to sort of manage and understand. So let's get into some more examples. Okay, so here we're speaking about the idea that everything in Python is an object. So there's the datetime Python library. I don't know if you've used it before yet, but there's nothing crazy happening here. This is the built-in Python library for date manipulation and all of that stuff. So we have the idea of construction. What's going on here? Well, in order to create a date object, I need to give it a date or some information that it can build a date from. So the date constructor is always the name of the object itself, and it will usually be able to accept some data as an argument. It has to be specified. For example, this can accept 3 integers, year, month, day, and it will basically accept that data and then construct an object. So now, today is an object storing data, the date, 26/9/2019, and some built-in methods or functions that can manipulate the data it stores. Okay? So I said that objects are data and methods. And so what's something cool that the date object does is it actually exposes the data to you in what are called properties. Now, properties are basically the term for a variable in an object. So there's a question in the chat about what's the difference between a method and a function. A function is a list of operations that you execute associated with an identifier. Okay, so you all know what a function is from C. When a function is in an object, it becomes a method. It's just a different term for basically the same idea. Well, when a variable is in an object, we call it a property. And so you can see if I just comment all of this out, program, and I run object.py, nope, not program, Python, I run object.py, you can see that these 3 print statements, today.year, today.month, today.day, print out exactly as we'd expect, 2019, 9, and 26. So Python has constructed the date object and assigned these values to some properties. So now a date object, if we go back to our whiteboard, and I hope my iPad doesn't run out of battery. Let's go over here. A date object has, some properties. And it'll have some methods. For example, one's called weekday. Now, these methods typically will contain a bunch of instructions that read the object's properties. So let's see what weekday and C time do. I don't actually even know. Let's comment that out. And let me actually comment these out, just so we're clear on what we can see. Oh, and I need to move my... camera a bit, I think. Okay. So I think what this is saying, I think what weekday is saying, yeah, okay, return the day of the week. So basically, it's calculating that the 26th of the 9th month is the 3rd day of the week, right? So this is a method, it's got some functionality, it has to know what to do. And what it does depends on the properties that it's stored. And then ctime is... Okay, return a ctime style string. So it's formatting the date object into a specific string format that's a standard format that we can interrupt with. So the key thing to take away in Python, everything is an object. Objects contain data called properties. Objects contain functionality called methods, and that's the new part. And like I've mentioned many, many times, almost everything in Python is an object. Let me run through some chat questions at the moment, and then I'll keep going. Okay. So if we use list.reverse, the list has been modified and we do not need to assign it back to list. That's exactly right. So one difference with, I got rid of the list code. One difference with objects and methods is that when they modify the properties, they're modifying themselves. So you can imagine if we have a really simple example here. Let's just got, my object. If I make this nice and big so I can fit it. Let's say we've got this x and it's an integer starting at 0. And we've got a method called add1. And add1 says, hey, take x and add 1. When I call my object dot add 1, right? The same way that we call properties of a struct, we use a full stop here. I use a full stop to call a method. When I call add1, it jumps over to the object, starts executing the code. It goes, oh, I'm changing x here. What's x? X is 0. X is plus equal to 1. Get rid of the 0, make it 1. So now when I read my object dot x, what's it going to be equal to? It's going to be 1 because things happen in place with methods. I've mentioned the difference between a method and a function. A method is just a function that belongs in an object. Add1 is a method here. So here, date is the variable and day, month, year are the properties. Correct. Date is the variable storing a reference to a date object that we created and initialized with the properties containing data from 2019, 9, and 26. Date, month, year. No, these are not methods. These are properties. How do you know if something's a method or a property? We call methods with the function syntax. We don't call properties. We just read them. So these are not methods. These are properties. So Muhammad, objects and classes are like structs, except they include methods. Absolutely. That's one of the major differences. Now, we have some questions on classes, and we haven't spoken about classes yet, so let's start doing that. Can I define my own objects? So all the objects we've been talking about here are built-in Python object types. Date comes from the datetime Python library. List is a built-in native object type. These are all objects that come with Python. There's many, many of them. They do many, many things. There's a lot of functionality that we get from them. But just like we create our own structs, we can define our own objects. So what is stored in the properties and what methods are associated with an object, we can define ourselves. I mean, in this crude example, right, my object is my own object type that I defined. How do I do this? This is what a class is. So in object-oriented programming, a class is the definition of an object type. It defines what properties are available and what methods are available when we go off and later create objects from the class. We do not have you create any classes yourself in this course. We talk about them a little bit, but it's basically a bonus lecture later in the course. We don't formally cover it. You use objects in this course. You do not need to define custom object types, okay? However, it's very common when you're doing object-oriented programming to define your own types. It's extremely common. There's just other courses for that and other places where you will learn that. But just so you know, a class is how you define a custom object type. You can go off and Google it and do what you want with it. We have a bonus lecture on it later in the course, but it's not really part of this course. Okay, don't use that feedback QR code. It's wrong. I've got the feedback form pinned in the chat. That's a really high-level, quick overview of objects in Python. I know we went really quick, but once again, we want you to do stuff with objects, not necessarily delve really deep into a strong understanding of how they work and things like that. So any questions on objects in Python? So Ella's asked, excuse me, can we create our own classes for the project? Yeah, I don't think there's anything stopping you from doing it. You don't need to, but you might want to, and that's completely fine. The project is basically, as long as the tests pass, and yeah, you can sort of do whatever you want, really, as long as it's reasonable. So Justin asked, is the data store in the project also an object? Yes and no, right? So it's not a custom object type that we designed with a class, okay? So in that sense, no. But if you think of the data store as a dictionary, right, which is one of the common ways that people implement the data store, even a dictionary in Python is an object. So that's why if you ask, is X an object in Python? The answer is almost always yes, because everything in Python is an object. So the data store, no matter what it is, basically will be an object. But it's not a custom object. And just to sort of prove that point, if I get a myDict is equal to a dictionary, with name, and it might be, Jake, whatever. And I print my dictionary. Again, in VS Code, when I use myDict dot and I can start seeing the list of methods, you can see that there's built-in methods on the dictionary type, just like there are on the list type or any object in Python. Why is this? Because dictionary is an object containing key value pairs and a set of methods that can read and manipulate the data that dictionary is storing. So for example, I can get all the values out of it. This is a method that can read the internal data within the myDictionary object. So everything in Python is working like this. Okay, time to move on, I think. Feel free to ask any last questions as I start moving. Alrighty. Oops, that's the wrong one. No, it's not. Sort of the wrong one. Okay. Yep, looks good. Alrighty. So this is now the next lecture topic. If you saw from last week's lecture video, I went through and did the timestamps. So hopefully that worked well for you guys. Let me know any feedback on that. So you can go through and just click the chapters to jump between the different lecture content in the video. So let me get a drink of water. Okay, 3.2, the lecture on a form of testing, so different from what we've covered before, right? Not using PyTest, but something called linting. So what the hell is this word and what does it mean? Well, when we write Python code, when we write any programming language, and again, this is something that hopefully has been hammered into you from COMP1531. When we write code, there is a style, typically, that the institution that you're writing that code for wants you to adhere to. So there's a style guide. There's a set of rules for how you should write your code, the rules and regulations about how you should name your identifiers, what case the identifiers should be, what should a constant look like versus a variable. Even things like what's the maximum number of characters wide your lines should be, what's the maximum number of lines within a function. All of that is defined in a style guide. But as files get larger, as projects get larger, for example, as you work on the project, the group project, it can become difficult to make sure that your style is maintained across large projects. I mean, if you think of a company like Google and their monorepo and the code base in there, it's millions and millions and millions lines of code. You don't want some poor sod having to go through and maintain the style guide and check it for all of those millions of lines of code. So that's where linting comes in. So linting comes from the word, when you take the lint out of your clothes, and that's sort of what it is doing for code. So don't confuse sort of PyLint from programming style sort of generally. So typically, style is designed to make sure that code is consistent and readable to users. Here's a nice quote, that programs must be written for people to read and incidentally for machines to execute. And that's absolutely true. Code that we can't read and consume and understand is not very good because it means people will have trouble working on it in the future. And what makes code readable is consistency. And that's why we have code style guides and linting tools. So it makes code easier to follow. It makes it visually glanceable because we already know how it should be looking and how it should be working. And it can even make it easier for us to detect bugs by avoiding specific bad style that can more often lead to bugs. Okay. So how do you know what good style is? Well, sometimes it's obvious. Sometimes it's just a choice that needs to be made. So, for example, common ones in Python is a snake case versus camel case, tabs versus spaces for indentation and other things. This is really important to understand. There's no real point arguing over every specific style decision that's made. What's important is that you just are consistent and adhere to what you're told. So when you work for a company, they'll have a style guide for each language. When you study a course like 1531, we have our own style guide that we want you to adhere to. Typically, this is what we do as well. We sort of follow on from what really large companies have learned across their massive code bases. They're writing more code than anyone else. They're coming across the edge cases that we don't have enough time to come along to. Google, for example, Google advertise their internal style guide with a bunch of rules, and they'll even create PyLint configuration files. We're talking about PyLint in a moment. And so typically what people do, what smaller companies do, or what many companies do, is just follow on from what your Googles of the world do. And it's really sort of nice that Google give us what they do. Oh my goodness.
Feel free to ask me a question.
Oh, you just heard my Google Home got triggered and scared the crap out of me. Oh, okay. And you might modify those rules a little bit, but typically that's what we do. Okay. So you've decided on a style guide, right? It might be the Google style guide. Now you want to make sure that everyone that writes code, for example, all the students in COMP1531, that every time you guys write code, that you're adhering to the style guide. Whoops, I'm in the wrong lecture. That you're adhering to the style guide. And so how do we do this? Well, we write more code, right? Because we're programmers. That's how we solve problems. We write a program called a linter that checks our code and makes sure that we're adhering to our linting rules. To do this, we have something called, we use a concept called static analysis. Now, what is static analysis or statically analyzed? Static analysis refers to the concept of analyzing the code in a file just as like we do as we're reading it as humans, right? So static analysis will come along and actually, it's another program that can read and be like, oh, there's an identifier here, followed by a space, followed by an assignment, followed by a space, followed by a dictionary with one key and one value. And that's line one. That's what the static analyzer is doing. So it's coming through and it can understand the syntax and the code. It's not executing it. This is why it's called static, and this is the big difference. Static analysis does not execute the code. It does not create a piece of memory and store this data in this variable or in this object. It just tries to understand the syntax of what's written. So literally it comes along and it's like there's an M, there's a Y, there's an underscore, there's a D, there's an I, there's a C, there's a T, there's a space. Okay, that must be a variable. That's what static analysis is. And static analysis is how we can do linting. Static analysis is used for a bunch of different problems as well. C compilation does some static analysis, for example, checking for unused variables and things like that. Your code editor does a bunch of static analysis. They're basically static analysis machines. And linting uses static analysis. So it can come along and you can imagine that a linter is going, okay, if I've got a sequence of characters followed by an assignment statement, there must be a space around the assignment statement. That would be like a linting rule. And so it can determine, well, if that's not the case, then this line does not adhere to the rules of the linter. And that's basically what a linter is doing. It's just coming along, looking at your code and looking at the rules that it knows about the language and the code and saying if it is and isn't meeting the requirements. So that's what linting is conceptually. PyLint is another Python library, a tool for running a linting sequence or via static analysis on Python code. All right, let's actually run it. Here we have 4 lines of code. Now, if you just look at this yourself, I'll make it a little bit bigger. Does this code adhere to the default PyLint rules? Well, I can tell you already that it doesn't. So one rule, for example, is that there should be a space surrounding an assignment statement, and we don't have that. So we can already tell that this is not typically adhering to the typical Python linting rules. But this could be a massive code base. How do we automatically detect that? Well, we can run PyLint. We run it sort of similarly to how we run PyTest. So I can run PyLint. If I run PyLint, it'll just run it on every Python file in the project or in the directory. Or I can specify a specific file, like this lint.py file that I'm working on. I run that. It goes off. Let me make that a bit bigger. And it does its static analysis. It lints PyLint, it lints lint.py, and it gives you some output. This is all it does. It doesn't change anything. It doesn't do anything. It just tells us what's wrong with the style of our code. And so you can see, for example, it's missing a final new line. So typically we have a new line after the last line of code. Now, if I rerun Pylint here, you can see that that linting error is now gone because I fixed the issue. My code has been rated at negative 2.5 out of 10. That was quite mean. Okay. What are the other issues that it's telling us? Well, you've got bad indentation, Jake. I expected 4 space characters for my indentation, and you're only using 2. So let's put another 2 space characters there, and let's rerun our Pylint, and hopefully our score starts to improve. Okay, I'm in the positives now at least. Okay, cool. Now we no longer have that specific error. So you can see that the Pylint, the Python linter, is giving us tips on what it thinks we're doing wrong. So what are some other ones? We're missing a module docstring. Yeah, okay, let's not worry too much about that one. Name doesn't conform to uppercase naming style. Okay. Interesting one, but let's do that. Consider using enumerate instead of iterating with range and length. I mean, this one's really interesting and really cool. Not only is it telling us to fix our style in terms of formatting and identify names, it's actually smart enough to tell us that, hey, you're iterating over a list using the range of the length. And that's typically not the Pythonic way of doing it. Can you just use an iterator instead? And if we all remember how to do that, we can just say for score in scores, print score. It's actually telling us that it prefers this. This is more Pythonic, and this adheres to the linting rule that's been obviously specified. Let's run Pylint again, and you can see that now we only have one warning coming out, and that's that we're missing our module docstring, our scores going up, and in VS Code, when it gives us those suggestions, you can see the underlined. This is coming from running Pylint on the code as well. So Pylint's actually sort of been run twice on this code. Once in the console when I'm manually running it, and actually Visual Studio Code is in the background constantly running Pylint every time I make a change, and it's telling us that, hey, you're missing the module docstring. Oops. Now if we just, oops. I'm just getting the module docstring. Okay, this is a module docstring. It describes what this module does, or what this program does, basically. And now if I run my Pylint one more time, we pass all of the Pylint rules. We are perfectly adherent to what Pylint is configured for us, so we get a 10 out of 10. Okay. You guys can work on getting the high score, the lowest score. That's all Pylint is. Sure, the implementation of a static analysis and a linter might be sort of complicated and in depth, but the usage of it is really simple. It has a configuration file, or a default Python configuration file, and it runs through our code. It doesn't execute it. It just looks at it basically and tells us if our Python code is adhering to our linting rules. By default, it's quite strict. You can modify Pylint so that it passes like 10 out of 10, even with, for example, missing a docstring, for example. We can modify it. We can use the IDE add-ons that I mentioned. So that's, if I miss, I guess, there we go. Give it a second to run. We can use Pylint within Visual Studio Code automatically to sort of do this for us. This is typically how you would use it. You wouldn't necessarily need to run Pylint in the terminal yourself. I'll talk about why we do use that in a moment. And So here's another spanner sort of in the works. Pylint does not modify the code. It just tells us what's wrong with it. But there are other tools, and one of the big ones for Python called AutoPep8 that actually can automatically look at the linting output and implement the changes to adhere to the linting rules for us. And this is typically what I use, for example, when I write Python code. So let's do this. Let's go back to something like this. Now, AutoPep8, which is the default, the sort of common Python formatter, it is different from the linter. This is a code formatter. It's fixing specific formatting issues, not necessarily, like it's not going to go off and add the module docstring. Like it doesn't know what the module docstring should be. It's not some intelligent system, but it's going to fix some formatting issues. So let's install it. So pip install AutoPep8. Now, again, I've already got it installed. So for me, it's not going to actually download and install it. But if you run this, it will go off and install it. There we go. So I've got AutoPep8 2.7. And now I just run AutoPep8. It's another Python module. I can give it lint.py. I've gone back to the previous sort of ugly, bad code, and I just run this. And you can see it actually spat out. Oops. How cool is this? It spat out the code, but it fixed many of the formatting issues with the code. So for example, it added the space around the assignment statement. It added back the 4 spaces, or not added back, but it changed, it actually generated new code that fixes the formatting according to the AutoPep8 default rules. And like we can integrate Pylint into Visual Studio Code, we can integrate AutoPep8 into Visual Studio Code. And so when I hit, I think it's Control-Shift-F, for example, on my computer, on a Windows it might be, Control-Shift-F. Mine's, I think, Option-Shift-F. It actually ran AutoPep8 for me and implemented those changes directly in line. It didn't need to, I didn't need to go off and, you don't want to, be copying and pasting code from the terminal back into your code file. It was able, just in one button, to apply the formatting rules for me. And that's what AutoPep8 does. It's the de facto formatter. I'll give you one insider tip. This is what I do on any project. So in settings of Visual Studio Code, which is where I work, if you don't use Visual Studio Code, that's completely fine. Your editor probably has a feature like this if it supports things like AutoPep8 and stuff. But this is what I do when I'm working. So I do format on save. There we go. And I enable this option. What does it do? Well, if a formatter is available for a specific language and the file is not saved, it will it'll apply the formatter on the code for me. So let's undo this. Well, I can't even show you now. So the file's not saved. I've undone the changes. All I'm hitting is save here. Command S, and it applies the formatter on save. You enable this option. You never have to think about formatting again, mostly. You don't even have to think about how do I actually run the formatter. You just save the file and your code will be formatted. This is why really there's no excuse for having poorly formatted code if you're using a modern editor stack like this. So 100% recommend if you're using Visual Studio Code to turn on format on save. And it works in other languages too. If this was a C file, it would apply the default C formatter. If it was a JavaScript file, it would apply the JavaScript formatter. So that's my pro tip. Okay, we can, when we're running something like Pylint, we can specifically give it flags to enable or disable specific checks, but we don't have to worry too much about that stuff. Okay, the other important thing, I mentioned before that Google Python lint style. So if you download here, it downloaded the Google Python .pylint.rc file. So you can see it's a big file with a bunch of rules for how Google want their Python styled. And if it's in the directory, and yeah, that should actually be a, if I rename this, a .pylint.rc file, I think. Yeah, I think that's right. If this is in the directory when I run pylint, let's see if I undo that, or yep, undo that, and then I go lint. Well, this is troubling now. Okay, lint, pylint, lint.py. Okay, you can actually see that that worked, I think. If you remember, this was the default code that I first put in, and there were 4 or 5 warnings in the Pylint when I ran it, because it was a negative 2.5. With Google's Pylint configuration, it was automatically picked up by Pylint, and it actually modified the rules. And so you can actually see we've got a higher score. So obviously there are some default rules that Google doesn't really care about. And you can say, okay, so you can see that Google actually want 2 spaces, not 4. Oops. But I can't save it, because when I save it now, it's formatting back to 4. But yeah, so you can see that Google have their own set of rules. You can put the pylint.rc file in the directory alongside your Python files, and it will automatically run that. Or you can actually put it anywhere on your system and just point pylint to it. Okay. Okay, so let's talk about what this means for you, your project, and your labs. From the week 3 labs onwards, so this week's labs onwards, we will actually, so when you push your lab work and your project work, we used to run PyTest, right? And we would test that your work was correct and passing the tests. We will now also be running Pylint automatically, and we will be making sure that your Python code not only passes the tests, but is correctly formatted and adhering to a set of rules. So Pylint would be now part of your labs, including usage of your project from iteration 2 onwards. It's also going to be added to the GitLab pipelines, so automatically we'll be Pylinting your code. So make sure you're linting your code locally as well. If you set up the formatter in VS Code or whatever you're using, you won't even really need to think about it. It'll automatically be happening. And you can run Pylint yourself. Yeah, absolutely, Zach. You can run Pylint yourself to know that it's all working. If I actually go to GitLab and I go to students, let's actually go to Zach. I'm picking you out. Let's go to a week 3 lab. Here we go. There's a couple. Okay, I was hoping that we don't actually have a Pylint RC file here. So I think we're just using the default Pylint configuration, I believe. But it'll be clear if it passes or doesn't pass. So basically, the pipeline will tell you if it failed Pylint or if it failed PyTest, and you'll be able to fix it. But you could also be able to test it locally as well. Any code that has Python writing will have a Pylint. It's the one Pylint. You won't even be thinking about it. No one will not pass a lab because they failed Pylint, right? It'll just be such an easy thing to fix. So don't stress about it. It's just that when you work in industry and you write code, the code quality and the code formatting gets checked, so we're going to check it too. You can't change the Pylint format, because then you could just turn it all off. And we automatically test it on the back end, so you can't really modify it. How do we use Pylint again? There's a few ways. You can just run Pylint just like you run PyTest. Can you see that in the lecture? You just run Pylint and then you give it a file. Or you just run Pylint in the directory. This is what you'll actually do. No, that didn't work. PyLint, do I just go here? Is this what I do? Yeah, there we go. So if I go, what we do on the GitLab runner is we do pylint star.py. So basically any Python file in the directory, we will check it for linting. But I don't think we check it, for example, for the missing module docstrings, for example. So I'll double check that in the next lecture. We're talking about how we actually automatically test pylint. Okay. Will pylint be used for the project? Yes, absolutely. There is a difference between AutoPep8 and pylint. AutoPep8 is a formatter, not a linter. So for example, AutoPep8 isn't going to fix missing docstrings, but it will fix things like indentation and stuff like that. But typically they support each other. So if you're keeping your code formatted correctly, it's going to also appease pylint. And yeah, it makes the changes for you. That's the difference. A formatter fixes it too. Okay, any last questions on any of this stuff? Now, did I miss any chat? Oh, okay, I understand what you were asking now. Can you change the Python doc string format? No. That's actually part of the Python language, the format of it. So you can't change the format of the doc string. It's 3 double quotes, summary, 3 double quotes at the start of the file. Okay, I think that's all the questions previously. I think I got to confirm this. I'll confirm it in the next lecture. We're about to take a look at it, but I don't think we check for the module docstring. I think we turn this rule off. I have a feeling we use the Google pylint rules, which doesn't ensure that it's on. But we'll double check this in a second. Okay, that is the pylint lecture. Once again, the feedback form is linked to the top of the stream chat. Let's take a 5-minute break, get some beats back on, get some water, get some coffee, etc., etc. I'll see you back at 7 past, and we'll talk about it. So Hamish has asked, can we use 4 spaces instead of 2? I will confirm with you all the rules with the pylint in the next lecture, at 7 past 12 or whatever. I'll explain that how it works. But typically, yeah, you can tell pylint or AutoPep, hey, I want to use 4 spaces, I want to use tabs, 2 spaces, or I want to use tabs. You can change that. Okay, let's all get some water, have a break, and I'll see you back in a moment. Okay, welcome back. Is everyone back? What's the name of this background music? It's a Spotify playlist that's like DMCA friendly music. I can link the playlist. Sorry. Okay, there's the playlist. You can study to it or something. Okay. Oops. Is everyone back, ready to go? Refreshed, recharged? Cool. All right. I'm really excited about this topic. It's something that I work with a fair bit. And it's really useful. And it's used everywhere in industry. And it's called continuous integration. Okay, so what's going on here? Whoops. So why do we have this problem and this need for this tool? So in large projects, in large repositories with many people working on a code base, we need automatic ways to integrate things like we've been talking about: PyTest, PyLint, code coverage, even just things like checking, does the code compile that I've been running? Continuous integration, pipelines and runners, these are all related concepts, are ways that we can scale these automatic tests across large teams, large code bases with large numbers of changes. So continuous integration is the practice of automating the integration of code changes across multiple contributors, multiple branches, multiple variations of a project in a single software project. So basically, if you think about the pipeline of what it means to write code and commit it and push it to a server, so you write your code locally, right? That's down here. You push it to a branch and then you make a merge request into a main branch or a feature branch or something like that. Now, you don't just release that straight away because you might have made errors, problems, things you didn't think about. So before you release, you have to review it. Now there's manual review, and that's something that you will do in the projects and we all do in industry. So you literally have someone else in your team who is over the code base to look at it and basically review it, make sure that it looks okay to them as well. So that's like your manual review. That has a similar cycle. And then they say, yep, this is good to merge, or this is not good to merge and release. But on top of the manual review, we can have a continual, automatically integrated review. And that's what continuous integration is. So when it gets triggered, we can configure, but either on a merge or on a push. So you push some code changes, and then automatically it will try and, for example, build your code. Now, we don't build code in Python, so this wouldn't happen. Test our code, or do any sort of things, and then to lead to some sort of report or outcome on the status of what you pushed. And then if that all goes well, it can be released. So common things we do in a continuous integration pipeline is write tests, code coverage checkers, unit tests, integration tests, acceptance tests, etc. And these all get automatic, things like PyLint as well, and these automatically get executed and evaluated. So these tests will be executed by a runner, which is a program or an application that works with the version control system. So for example, Git and GitLab to execute the tests for us. GitLab doesn't actually have runners built in. It's like an optional add-on, I think, which we obviously have configured on the GitLab servers. But Bitbucket and GitHub as well, I think, have run. No, GitHub you can't self-host, I think. But you can actually. And they have runners built in. Okay. So you push code to a Git server. Okay. So these are two repositories, right? So if you think of this as the GitLab configuration for COMP1531, repository 1 could be, Tuesday 9 a.m. group 1, and repository 2 could be Tuesday 11 a.m. group 2. So two random repositories in the course. And there's a bunch of students in those repositories. When you push code to your repository, the repository will basically tell the GitLab runner, hey, I've got some new code here. Can you give me a runner to test it? The runner then gets allocated, it runs it, and then the result gets returned in the report. So, when you push your labs to GitLab, what's pretty amazing about this is that there are about 650 of you students in this course. There are maybe 5 to 10 labs per week. You do about 3 of them because you don't do all of the labs. So 3, times 650 plus all the project repositories. So there are thousands of repositories on the GitLab server just for COMP1531 in 22T1, right? Anytime you push to a repository, a single runner on the GitLab server runs PyTest basically on that lab, returns a result, and then goes back and runs the next one. So the poor runner is a very, very busy, overworked piece of code, right? There's a single runner, I believe, for our GitLab server. Maybe there's multiple now, but there used to just be one, which is really cool. So there's a bunch of links to go really in depth with continuous integration. It's really important. You can grab these links from the PDF notes. But basically, we're just going to do a demo, I think. Yeah, I've spoken about that. So we're using it in GitLab. That's fine. There's some overviews about the GitLab specific runners, but you don't really need to go too in depth about it. You should just be understanding the concepts. Okay, let's do it. Okay, so in COMP1531, we have some runners configured. So basically, I'm going to configure this myself. Now, let's just jump into it. So I've got this repository called CI demo. I made this just last night or something like this. So this is just a repository in GitLab. and I've pushed some files here. But what I'm actually going to do, if I come over to here, I'm actually going to get rid of that. Actually, let me just delete this file. Okay. I run git status here and I can see, okay, my mug needs to move. Okay. So I deleted this file here. I'll talk about exactly what this file is. Let me just add this. Oop. Remove CI config git push. Okay, so I've just pushed now. This is just a standard repository. If I refresh here, this is what I wanted to show. We have a repository here, and if you noticed, there's no pipeline marker here. So this is the default behavior for any repository on GitLab, and even something on GitHub or Bitbucket or whatever. This is just a repository with 2 code files and nothing else. Now, I want, and I've got this program file here. This is the same, code that failed the pylint earlier. So if I locally run pylint program, you can see that it will tell me, yeah, I got that negative 2.5 score. Okay. Now, rather than, if I'm managing, 10 people, 50 people, I don't want to be going around and making sure that everyone's run pylint properly. I want it to automatically be evaluated anytime someone pushes code to the repository. So how do I do that? And this is where now it starts becoming dependent on the Git repository server that you're using. So this will all be for GitLab. If you're using GitHub, it will have a different format and setup, for example, that you need to use. So in GitLab, how does it work? There needs to be a .gitlab-ci, I think that's what it is. I've already forgotten. Yeah, .gitlab-ci file in the repository. As long as this file is in the repository, and has to have a period at the start. This is typically to show that it's either a config file or a hidden file. Basically, if this file is present when the repository is pushed, it will look in the contents for it to determine what it needs to do. Okay, so, oh no, it's a there's .yaml. Yeah, that's it. There we go, it's worked. Oh, my screen is cropped. Thank you. Okay, there we go. Thank you. Okay, so I don't know how much of that you saw, but basically I've just created a .gitlab-ci.yml file. Okay, well, so what the hell is going on? Well, GitLab is basically saying, I want there to be a .gitlab continuous integration file. And what's the type of this file? It's a YAML file. If anyone's not heard of YAML, it is a human readable configuration file format similar to JSON, but designed for human editing and reading, whereas JSON is designed for computing, program edited and read configuration. So basically, it's a standardized configuration file. You'll see YAML files all over the place. Yeah, yet another markup language. Okay. So in this file, there is some specific syntax for how the config needs to be presented. You list the stages that should occur when the pipeline runner is executed. So, for example, I've only got one stage in this config, and it's called linting. What is linting? It's pointing to this stage. So this is a stage that defines what I actually want to do in the stage. There's something called an image. What is this image? Now, in order to run Pylint, okay, Pylint is a Python module, so Python needs to be executing to run Pylint, right? So we need a computer to execute the Python program. We do not want to just execute arbitrary Python programs on the CSE GitLab server's machine. That could be catastrophic. All it would take would be to someone to upload a Python program that does something really nasty. You know, it could be unzipping an infinite file, or, you know, you can imagine all the security opportunities that could be at risk there. So how GitLab gets around this is to basically sandbox every single running environment in a virtual machine. Specifically, it's actually using a Docker container. So this is the image specifying the base environment for where it will run Pylint. In this Docker environment, so you can see that this is a custom image that we designed back in 2020 T3. And in this image, we actually specify, you know, the version of Python we want to run on, like what operating system is the image. So is it like an Ubuntu, or is it some other variation of Linux? What is it? What's in there? And what version of even Py, like all of that is configured in this image. You don't have to do any of this. You don't have to worry about how to create this. We're definitely not talking about Docker in this course. That would absolutely destroy it, destroy me and destroy you as well. There's not near enough time, although Docker is an awesome innovation in technology, and I love it, but we're not talking about it. But basically, we have this, you can think of this as a virtual machine image, okay? Well, that's why it's called an image. And then, okay, the script. What do you actually want me to execute on this image? And all I want to execute is Pylint on all the Python files that's present in the repository. And that's the config file. So I've added this config file to the repository. I'm going to add this. Okay, I'm going to commit it. Add CI config. Now, just to remind you, if I go back to the repository, this is what the repository looks like. There's 6 commits, 1 branch, no Pylint, no runner, nothing like that. So I'm going to git push this. You can see that pushed, no problems. I come back to the repo, I refresh, and you can see already how quickly GitLab has identified that there is a GitLab CI file in the repository now, in the root of the repository. So, hey, I need to actually look at it. And you can actually see, I think it's already completed. So it's saying, well, what's in the pipeline? There's one stage in the pipeline called linting, right? That's our stage. Let's click on it and see what's happened. Here we have the output of the runner. Whoops. So we're using the COMP1531 primary runner. So this is the same runner that we use for all the lab marking, all the project marking, blah, 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 blah. Hey, we're using Docker with that image. We found the image locally. If it wasn't found locally, it would actually download the image from the Docker image repository. But we're using this image, so that's fine. We don't really have to worry about that stuff. It's preparing the environment. So it's getting the tools and the systems ready that it needs to run this runner. It's reinitializing the existing Git repository. So it sets up the project basically locally on that new image it's built up. Checks out the files, and then you can see it goes, okay, I'm now executing the script stage of the job, and it's running pylint.py. So this is a virtual computer on the GitLab server, on the CSE machine, that is now running pylint.py. And as we know, the program.py that I pushed had some Pylint issues. And here we can see that it has spat those issues out. And because Pylint, the last thing that it ran, spat some issues out, the job knows that it failed because Pylint told as its return that it failed. And that's basically the pipeline. That is continuous integration. I pushed some code and it integrated the code with the checks, executed the checks, and told me, hey, there's a problem. And now I know just from pushing, now that it's updated as a failed pipeline, that something went wrong here. So let's actually fix up the Pylint issues. Now I could go over here and look at the Pylint output and try and fix it up, or I could just run Pylint locally. and we will get a bunch of issues. Now these are issues that I already fixed earlier. We want a missing line. We want 4 levels. We want a doc string. My awesome linted file. What else do we want? We want name needs to be uppercase, and we want this to be for name in, oh no, score, sorry. Oh, and add that like that. Okay, I've changed the file, I've linted it, I run pylint. Okay, we get a 10 out of 10 now. So I've not done anything else, I've just fixed my program.file. I'm gonna add the file, I'm gonna commit it, fix program.py for pylint, and I'm gonna push it. Now we've got to be quick. So, you can already see it's back to pending. If I refresh now, it's still pending. Okay, let's try and catch it. It's running the linter. You can see it's executing. Now, sometimes you need to wait because the runner's busy doing something else. You can see right now it's executing the script. It's run pylint. I got a 10 out of 10 and the job succeeded because pylint did not return any errors. And now when we go back to the parent repository, we have our beautiful serotonin-inducing green tick. And that is basically a continuous integration pipeline. We can specify what it does, on what files, and now this is just using pylint, but you can imagine that we could do, you know, okay, we've got 30 minutes. We can probably get testing. Do you want to see do you want to see me write some py test for the linting, for the continuous integration? But you should be able to get a basic overview of the of continuous integration in the pipeline. Okay, let me look at the chat. So Ricardo asks, does the file need to be present in each branch we push to, or can I simply have it in the master branch or the main branch? That's a good question. I think it needs to be on every branch, but you raise a good point. So I'll talk about branches in a little bit. I'll talk about it in a second. Okay, so that's a good point actually. So if you go and look at, let's go here, GitLab CI config file. Let's go look at the documentation, right? So if you've got runners available, create a GitLab CI file, and this is where you can define your jobs. Okay. So I just want to get some of the config here and show you about some of the common things that we can do. That we change. Okay. Whoops. That's automatically, what did I just do? Now, here we go. Okay, so this is one thing we can do. This is what I wanted. So we can actually say that I only want linting to happen on merge requests. So by default, it was happening on a push. But we can say that, hey, there's no point doing this every single time I push, which for pylint you probably would. I'm just demonstrating here. But we can change it so that it only happens on merge requests. So let's add this. Update. Oh, did that not run? There we go. Git commit update CI for merge request only. I push git push. That's gone push. Now, if, where's the repo gone? What you can see here is that the pipeline is not shown anymore because I told the GitLab runner that I only want to run the stages, the CI, on a merge request now, not on a push. So it's no longer running it. So you can start seeing how all the different ways we can control how certain things work, and we can have specific stages that only do certain things on specific actions. So you could only do a pilot on a push, but do certain things on a merge request, etc., etc., etc. So Steve asks, I don't have a pipeline button in the Git merging, but I received an email saying I failed that pipeline, but you do pass locally. Not too sure exactly how that one was set up. It could have been, for example, only a merge request check. Yeah, I'm not too sure. You can ask your tutor and stuff about that. Okay, how do we set up PyTest and PyTest? I think you mean PyTest and PyLint in the YAML file. So let's do that. In GitLab CI, okay. Well, basically, I think what we do is we add a stage. Now, I'm not a GitLab expert, so bear with me. I use GitHub most of the time. But let's call this testing. Let's call this testing here. The image is the same. I think that makes sense. Now, the script is going to be different, but similar. And it's just going to be PyTest startup py. And let's do it only on, or let's not do it only on anything. Let's just always do it. Let's see if this works. Now, we don't have any tests set up, so we're going to need to write a program test file. And we can just, test method assert true. Oh, true is equal to true. There's some in fact, I don't even need oh no, I do need a method, don't I? I guess, does it need? Is it assert true? What's wrong with this? Unexpected indentation. I've gone blanked. Actually, can I just do? Can I do it in here? Oh yeah, def. Thank you. Yep. Cool. All right. I think that should pass. So if I go pytest star.py. Cool, that all passes. All right. Yeah, thanks guys, I blanked. All right, so this is a really crappy test, but it does the job. So we've got this in here. We've told it that we want it to run PyTest on startup py. I think this all looks okay. Let's add all these changes. Add PyTest to CI runner. And let's push that. Let's go back to the home page. Let's refresh. You can see we have our status here. We can see it's got 2 stages, so that's looking really good. It does linting first, because I told it to do linting first, and it's sequential, so it only does testing if linting passes. And so this is where we can start being efficient. Like, there's no point doing the expensive operation if the cheap operation fails. So this is how it's... Okay, the linting actually failed. Now, it's actually probably linting the PyTest file. Yeah, so that's interesting, right? So I didn't even plan for that to happen, but obviously, like, I've written, so it's saying, like, for example, you should just assert that that's true. The parameters are unnecessary, sure. What else is this? It wants another docstring module. Testing doc module. What else does it want? All right, this now wants a method docstring. Oops. Testing method. All right. I think Does it? No. Does it go here? I think. Yep. Okay, is this saying the actual file it wants it to be underscore? All right, is this everything? Now, if I go pylint program test, does that pass at 100%? Okay, it does. So pylint star.py should be 100%. It is. Okay, beautiful. So you can already see how like the pylint CI caught me, you know, from writing failing pylint code here. So I add this, you know, this is quality, fix the program test formatting. I push this up and we see what happens. So we go back to the repo. Let's see if I can click. We refresh. You can see, oh, it's mid running it. So I'm guessing it's, okay, it's running the linting right now. That looks like it succeeded. I'll go back, I'll refresh. It happens pretty quick, so you gotta be careful. Now it's doing the testing, so it's getting another image built. Okay, it ran PyTest and it succeeded because our tests pass. And you can see that we'll have the beautiful green tick on the main repo. And that's space, and you can start building together your continuous integration if you're working on projects yourself. One optimization thing here, something that's not very good, is that you can, because these are two separate stages, it needs to pull down the two virtual machines separately. So what would be much more efficient is just to have one testing stage that runs pylint and then pytest in the one environment. This would be a lot quicker. So if we just do that, optimize CI, push that up, go back to the repo, refresh. What you'll see is there'll only be one stage, and it will just do, once it starts, it will just do the pylint and then the pytest immediately. So it'll be much, much quicker. There you go. So it ran pylint, 10 out of 10. Then it runs pytest, 10, that passes. So there was, no real need. Unless you needed to have different environments or something, then this is a lot quicker. Cool. And this is how we auto mark all of your repos. If we look at the pipelines, can I see them? I forget where they live. Let's go here. This is a specific pipeline. Yep. So these are all the pipelines that we run all, constantly. 6 days ago, if we release the labs, it goes through a pipeline, updating the student list, updating the groups for the project. We have a very busy runner on the GitLab server, don't we? Anytime you push a lab and it checks your work, that's a runner. We've got 15 minutes. Did you guys want to see how I use continuous integration in my personal project, in the project that I run? Oops. Or did you have any more questions on this stuff? Conceptually, is it all sitting with us well? There's a lot of moving parts, but it is really cool stuff. Okay, and we do some really cool stuff on this project. So this project is called Doubtfire. I speak about this sometimes. You will know Doubtfire if you've all logged into Formative. Formative is Doubtfire. So I build this tool. I build this project. It's used at a number of universities. This is the repo for Formative. In fact, it's all open source. So you can go here and look at every line of code in the back end, in the front end, in all the different services we have. It's all available there for your perusal. It's pretty cool. You can see there's my little face there. Okay, So how do we use continuous integration for formative? We do a number of things with it. So let me think here. So we have this, I think the main one is here in the deploy repository. And no, it might actually be, no, that's not true. Okay, let's go to the web repository. So this is the front end project. So the website, like formative dot, UNSWCC, blah, blah, blah. This is the code base for it. GitHub defines its pipelines in a .github directory, and then it's got some files in here, and you can see there's a workflows directory. So GitHub uses like some directories and stuff rather than just a single file in the main repo. And you can see that there's this deployment YAML file. So this is actually similar to the GitLab CI file. You probably can't see this very well. This is a GitHub version. And what we actually use continuous integration for on the front end, so we don't actually have, it's a complicated story. We don't actually have unit tests on the front end because they aren't supported with something that we're doing with the project. Hopefully in the future we'll have it. But on the back end, let me show you actually the back end. Does this link gonna work? Yeah. Okay. Oh, they're not here anyway. Let me just show you this. That's fine. So this is our deployment workflow. So this workflow only triggers when we're actually deploying a new version of the product. So this isn't for testing or making sure the code is linted correctly or anything like that. This is actually a workflow that occurs when we push to the development or the main branch. So we work on feature branches. So in Doubtfire, you can see when I work on a new feature, it goes into a branch. When I'm ready for the code base to be deployed, we push to one of the main or the development branches. So this only occurs when a development is about to a production release is about to happen. And what we actually do is we take all the code in the repository that's being released, and we go off and we actually use the CI server to create a Docker image based on the code base. And then we actually push the Docker image to our Docker Hub web server. So we actually create a deployment Docker image from the code base, and all I need to do is just push to the repo, and then it gets pushed off to Docker Hub. I know we're not really talking about Docker and stuff, but if you're not familiar with this stuff, it won't make much sense. So the Docker images, so the Docker web Docker image, Doubtfire web Docker image, sorry, is a Docker container, a Docker image that can create a container that deploys the website. So it's a virtual machine, it's an operating system that all its job is to run the front end for formative. But basically, I know this is sort of complicated, but it's packaging all the code that got pushed, creating a virtual machine image, pushing it to a server, and then on the production server at CSE, for example, I tell it, hey, just get your image from this URL in Docker Hub, and it will pull down the latest image and deploy my project. So that's what we use. One of the ways we use continual integration in this project, which is really cool. If you're not very familiar with Docker and stuff, maybe this won't make much sense, but basically it's like I'm pushing to my deployment branch, therefore I'm ready for a deployment. So now I want to package up all my code and release it as a new version. It automatically triggers when I push to my master branch. Okay, we have a second workflow file here, Node.js continual integration. And this is actually doing the equivalent of PyLint for JavaScript. So that's called, so this is running through the Angular CLI. It has its own Angular lint feature. So this is something like PyLint. And you can see on a push or a pull request, get an Ubuntu image at Node version 16 and lint the project and make sure that the project builds. So this is I should have started with this one, but this is most similar to what we were showing in the Python example. So this will trigger first on a push or a pull request, but only on a push to a very specific branch, our deployment branch, do we go off and actually do a bunch of work here to create the image. And if you see here, I can show you the actions. So GitHub call them actions. And you can see last night, very late last night, I was trying to fix a bug. So I pushed some changes to the 6.0 branch, and you can see it ran the linting job. So, you know, it ran, so you can see, I mean, this is a big code base and we have many issues that we're failing linting, but these are all warnings, not actually errors. So they do let you continue. And this, you know, this happens automatically. This is how we use the project in here. So this one that's waiting, if that's what you're talking about, this is the actual one that deploys to the server, and we need to manually review these because it's an expensive operation and we don't want to deploy something we didn't mean to. So with this one, it actually, I have to manually, you know, hit the big button to go off, create the Docker image and push it off to the server. So this one needs manual, and I'm not ready to push it, so I'm not doing it. Someone else will do it. But you can see all the different releases here, they automatically run. There we go, there's some issues there. That one failed. I think we had the wrong base image for something. I can't remember what it was, but this is how we use workflows or continuous integration in an example. Yeah, the Docker image stuff is really cool. Yeah, there are probably a bunch of security vulnerabilities. If any of you have some time, you can come across and feel free to please fix them up. I think they're only minor ones over the pretty critical ones. But yeah, if anyone's interested and you got some time, or after you do 60/80 or something like that, and you can anytime feel free to message me, and if you want to contribute to Formative or to Doubtfire, I would love that. Okay, cool. I wonder how we specified that we want it to be reviewed. I don't remember that. I don't remember how we did that. It must just be a setting in GitHub somewhere, but I don't quite remember. Anyway. Cool. Bit of an extra demonstration there. No, that's next week's lecture, or tomorrow's lecture, sorry. Okay, yeah, and that's all I had to talk about today. So that's pretty good timing. 9 minutes left. Any last questions in the last 9 minutes? Once again, feedback form is at the top of the chat. How do I get PyLint to recognize fixtures in PyTest? It seems to think a fixture is an ordinary function and doesn't like it. Oh, how do you get PyLint? You might need to... Yeah, I'm not sure, actually. You might need to specify... You might need to change the rules and specify a PyLint config. Is this what you're seeing? Okay, it doesn't want the name to be shadowed. Something like that. Maybe this is relevant. I'll link you to this. Let me know if this fixes it, Richard. What is a module docstring? Good question. I did sort of skip over that, didn't I? So docstrings in Python are part of the documentation for a program. So we have docstring documentation for methods, and we have it for modules. If we look, Let me see here. Is that going to work? Okay. Whoops. Whoa. Okay. So in test method here, in program_test, I created a test method function, and it's got a docstring called testing method. I imported this in my other file. What the docstring basically does is document what that method does and how it works. If I hover over that method, this testing method string, Visual Studio Code is actually looking at the docstring and displaying it to help us document what that method does. So it's just a format for an agreed upon conventional format for documenting Python programs. And it's the same with the module. So if I had a module called testing module, if I import program test, it tells me the docstring of the module. So module docstring is the docstring for the module. Function docstring is the docstring for a function. What's the point of using a docstring with when comments exist? Comments document what a code is doing to make it clearer for future readers or yourself. Docstrings are advertisements. They are API documentation. So if I do something like, and I go list.reverse, let's do reverse. If I highlight over reverse, damn it. Disable that. It's going to make me refresh in a second. Okay, reload. Okay, so, oh, that's not very nice. Is there no docstring here? Interesting. Oh, let me just use this as an example instead. So let's say that this is like, oh, I've just accidentally run it, but that's fine. Line 1, line 2, line 3, x equals 1, x plus equals, 1, whatever, print x. And I've got a bunch of comments. Oops. Okay. All right. And then whatever. When I'm importing, when I'm importing that test method and I want to read about what it's doing, do I want to read about all of the comments in the function? Like, would it make much sense to me if when I'm looking at the documentation for the method, I get the documentation, I get the code comment. Like, I don't care what test method does. Unless I'm looking at test method, then I care what the comments are saying. But when I'm just consuming it and when I'm just reading it, I don't care what the internals of the method's doing. So the docstring advertises what the method should be doing. The internal comments document how the code is working. And so when I read this, it's designed to help me understand what this method is for. And it gets understood by the editor and by some other tools so that you can actually document things this way. So docstrings for functions need to be the first line of the function with the correct indentation. For modules, they need to be the first line of the module. But again, if I put, like I could put this here. Like I could do that, but if I do that, like docstring is a formal Python convention. So for example, the editor knows how to read docstring and report it back. But A comment is not going to do that. Comments are for people reading the file. Docstrings are for people using the module. That's a good explanation. Is it possible for me to stream at 1080? I thought I did. I changed the settings today, so obviously it's not. But I don't know, is anyone an expert at this stuff? So I went to settings. I went to, what did I do? I went to video. 1920 by 1080. Ooh, I gotta change both. Okay, I'll do that tomorrow. I can't change it now. Sorry about that. I thought I did change it though, but obviously not. Yeah, it's a convention. Yeah, absolutely, it's a convention. Doc strings are used also. I don't think I can show you this. Oh, I can show you. Let me show you something. So this is another project that I've worked on. This is a C project. And let's see here, in the code base, yeah, okay. In the code base, we have a doc string like what we were talking about in Python, but this is one for C. And you can see so this is like the module docstring. This is a docstring for this particular struct. I think I wrote this file actually. Yeah, I did. This is the docstring for this function. You know, this is the docstring for this function. Okay, whatever. So the docstring specifies what the function does, what parameters it takes in, what it returns, etc., etc. It documents everything about the function. We can actually do that in Python too. So I think one thing that we can do is like if this is like this takes in X or like name, and then I generate the docstring. Yeah. So docstring has a syntax of its own that specifies that, okay, name, I want it to be a string and it's the name of the user. Prints, the name of the user, for example. And now when I look at the docstring, it tells me, hey, there's some arguments here and it wants a name that's a string. So you can see you can build pretty robust documentations from the docstring syntax. This is an equivalent in C. So we do this here. Now, not only does this help programmers learn how to properly use different functions, what they do, what they accept, what they return, we can actually do things because it is a syntax. And so if we go to the SplashKit website, which is for this project, and I go to the databases, let me show you this. So here's a function called database named. It returns a database and it's got a description here. When I go, I can actually we actually automatically generated library API documentation from the header doc. Whoops. So we can do more than just, it's more than just comments. It's a public declaration of what this function does. And we can actually consume it and generate an actual website from the header docs. This was a pretty cool thing that I've worked on. So it's more than just comments. And it is a convention. Cool. Well, it's 1:02, guys. I hope you learnt a lot. I hope you're going well with the project. I hope you're having fun. I'm having fun. You guys having fun? Yeah? Cool. Lots of fun. No. Is there anything I can do about the unused argument? Maybe post it on the forum, Richard. Without seeing the code, it's hard to figure out. So yeah, post it's a good forum one. Yeah, when it goes all right, it's fun. Yeah, I mean, I think that's that's normal. Well, if there's anything I can do to make it more enjoyable, put it in the feedback form, I guess. But yeah, I don't know. I think it's all cool stuff. This is all really cool, real stuff that we do in industry. So I know it can get overwhelming, but you'll thank us later, I guess, is the idea. Cool. Alrighty, well, I'll leave it there. Have a great day. I'll see you all tomorrow in the second lecture, talking about more fun stuff. Yeah. See you, everyone. Thank you for coming. Appreciate it. See you guys.